Well, welcome to week number 12 and lecture 16 of CS394R Applied Probability. This week we'll be starting a discussion on Markov chains, and a Markov chain is basically the last in our series of three probabilistic processes that we've been looking at for how to simplify the way that we approach probabilities. So far in this segment we've covered Bernoulli and Poisson processes, and in this lecture the Markov chain is our third process. Just as a quick refresher, we said that a Bernoulli process is really good for a system that is discrete time with non-variable probabilities and had no memory. And a Poisson process was the continuous time version of a Bernoulli process, one that still did not have a memory. It had no history of the past, and what happened previously could not influence what was going to happen next. Now, the Markov chain is the third of those, and it still requires that probabilities be constant with respect to time, but it does not require that probabilities be constant with respect to their past. So the previous states or the previous location or the previous probabilities can impact future probabilities. And so we'll see that as we progress through this series of lectures on Markov chains. So just at a high-level overview, we'll start out with an introduction to Markov chains, talk about some examples of common Markov chains, move into a definition of the Markov chain itself, and then look at two last properties here, in-step transition properties, and then ultimately the classification of what we'll call states. And a state is basically just a current value of a Markov chain. So with that, we'll go ahead and jump right on into lecture number 16.